While these ways of expressing alternating current values have their use, another method is more helpful. Since electrical equipment can contain both AC and DC circuits, it's important to be able to express AC values in relationship to DC.
This is possible using the effective value. In a purely resistive DC circuit, the power dissipated by the circuit resistance is given off in the form of heat energy. For an AC circuit of the same resistance, the value of AC voltage or current that would produce the same amount of heat energy as the corresponding DC circuit is called the effective value. Therefore, an alternating current with an effective value of 1 ampere would generate the same amount of heat in a 10-ohm resistor as would a direct current of the same value, 1 ampere, flowing through an equivalent resistance. Similarly, an AC voltage of a certain magnitude, 10 volts effective, for example, would produce the same amount of heat as a DC voltage of 10 volts. The effective value is also called the root mean square, abbreviated RMS. The effective or RMS value of any sinusoidal voltage or current wave is always 0.707 of the peak value. In order to determine the RMS value, E sub RMS of an AC voltage whose peak value is known, you multiply 0.707 times E sub peak. Similarly, the equation for the RMS value of current is I sub RMS equals 0.707 times I sub peak.
Let's try an example.
For a peak voltage of 100 volts, an AC voltage would have a value of 70.7 volts RMS. This means that a resistor which is placed across a 100 volts peak AC source will produce the same heat as when it's placed across a 70.7 volt DC source. The RMS value is the one that is usually used to rate AC voltage and currents. The home line voltage of 120 volts is an RMS value, as is the 240 volt industrial power voltage.
This formula can be rearranged to find the peak value when the RMS value is known.
Divide the RMS value of 70.7 volts by 0.707. This yields 100 volts peak.
Distinguishing between RMS and peak values is important. Before going on, let's try an actual problem that will incorporate several of the values and terms to which you've been introduced.
Let's begin with the standard AC voltage coming into your home, 120 volts, which is an RMS value. Let's determine the peak value by applying the formula E sub P equals E sub RMS divided by 0.707. Dividing 120 volts by 0.707 yields 169.7 volts peak. This instantaneous peak value occurs twice each cycle, at the positive peak and at the negative peak of the cycle. What would the peak-to-peak voltage be? You can determine this by simply multiplying the peak value times 2, yielding 339.4 volts in this case.
Shortly, you'll have a chance to look at some of these values on an oscilloscope. But first, let's
stop the program and complete activity number 3. When finished, continue watching the program.